So I'm going to start here with the idea of probability distributions that are based on population values. And as I said on the last slide, a probability distribution lists out every possible value that some variable can take on, and then its probability of occurring. So guess what? We already have a probability distribution for our superheroes here. And the probability distribution is what's written out right here. So I'm just going to say this is a probability distribution. And what it shows us is each of the different values that can occur. So if our variable is superhero drawn from the basket, these are the possible different values that we have. We know these are the values because those are the stickers that I put into the basket. And then we have the probability that each one will occur. So one thing to take note of here is that when you have a probability distribution like this, the total of all your probabilities should come out to 1. And as with the deviations, if you're rounding the probabilities off, it may come out to something a little bit different, but it should be close to 1 on either side. And the reason for this is that you have a probability of 1, or a 100% chance of getting at least one of these different outcomes here. So there's no version where you pull a superhero out of the basket and you don't get at least one of these superheroes. So another good way to check your work here is to see if your probabilities add up to 1. So that's all I'm going to say about a probability distribution that's based on known population values. Because we found it already on the last couple of examples, and you can see it's just listed out here like this. But for a lot of probability distributions that you end up working with in statistics, you don't actually know the population values. Instead, they're going to be based on logic or theory. So what I'm going to go through now is an example of a probability distribution that is based on just logic. And specifically, the probability distribution that we're going to talk about here is the probability of getting 2 heads, or the probability of getting some number of heads when you flip a coin 2 times. So for this one, we're going to say that our event, so the process that's going to generate an outcome, is going to be 2 coin flips. Our outcome, which we can also describe as our variable here, is going to be the number of heads in those 2 coin flips. So if you think about it, you can flip a coin 2 times, you could get heads twice, you could get heads once, or you could get heads no times. So there are 3 options here for our outcome. The number of heads in these 2 coin flips, either it's going to be 0 heads because you got tails twice, it's going to be 1 heads because you got heads once and tails once, or it's going to be 2 heads because you got heads twice. And for this, we're going to come up with a probability distribution that describes the chances of getting heads, the number of heads that you get in these 2 coin flips.